welcome back to my channel. Today we're going to be talking about the depth first search pattern. So the depth first search pattern. Now the next couple of patterns we actually have on this list, DFS, BFS, even the matrix traversal pattern, they tend to be related to traversing trees. Yeah, so we'll say tree traversal. Yeah, so question is, what is a tree and what do we mean by traversal of a tree? Yeah, so a tree data structure generally is some kind of data that, or some kind of data structure that we can use to model representation of data within the computer system, such that there is some form of relationship between the nodes of a tree, right? Or will I say the elements in the tree? Yeah, so to make it make sense, let's picture something like, imagine that we have, like, this is a point of a tree. So let's say like a leaf. Yeah, so you know how trees are represented. So we have a tree, then you know, I mean, pardon my diagram, but basically this single one is a leaf. Yeah, almost like at the tip of the entire tree, and then there are branches, there's a stem, there's all of this. Yeah, so the point is that there's a connection between this leaf and the other part of the tree. And the connection is through um a branch. Yeah, so the same thing. Yeah, so we could have like different leaves of a tree. Yeah, and then there is a branch that kind of connects them together. This could be a branch connecting this tree to this one. And then it could continue to go. Yeah, different branches. In addition to this, there could be so if you think about this now, this is like, if you're assuming that this is like the top of a tree. Let's just assume that this is the top of a tree now. And then the tree goes in this direction, downwards. There's an arrow pointing downwards here. And then for this one, then goes downwards this way. Yeah, this could be a representation of this tree. In another vein, there could be a bidirectional relationship in this tree, such that there is a relationship down and then there's another relationship up, two directions. Yeah, so this node in this tree points down. At the same time, the node in this tree points the other direction. Same thing happens here. So this is one way tree can be represented. It doesn't end there. Now imagine that we could create another relationship backwards. Yeah, so imagine that there could be another relationship between these two nodes. Yeah, and then you can just continue to imagine different connections. Yeah, so all of these determine the property of a tree. Yeah, but for these kind of questions now regarding DFS pattern, there are usually some specific kind of tree data structures that we could use them on. Yeah, although the DFS could be used on any particular tree representation actually, but in the sense of kind of questions I will talk about here, the DFS pattern is what works. Yeah, so what makes DFS DFS? So DFS is so I've talked about three. I'll talk about, okay, so traversal. Traversal of a tree basically is how we move around in a tree. That's what traversal means. So now coming to DFS. So DFS itself means depth first search. Yeah. So DFS, depth first search. So what this means is, let me just quickly bring back the picture we had. So we had something like this, and then we had this, we had this, we had this, we had this. So now, in this sense, DFS search means that you imagine that we somehow find ourselves here. Yeah, so I'll say this is start. Just imagine, just try to picture the fact that we find ourselves here somehow, and then we need to maybe explore this entire structure. Let's say we are looking for an element, for example. Now, remember we've gone through different examples of looking for elements. So let's say we are looking for an element, we're looking for the elements number 4. Yeah, and then let's say that 4 is here. Let's say where we are starting from actually contains the element 0, and we are looking for the number 4, this entire tree. How do we find it? Yeah, so that is where traversal comes in, and one traversal is DFS search. So what it does is it goes depth first and then it searches. So depth first search, that means that we, for every node, so if we start from here, we can see that this node directly links to 4 nodes. Directly. Yeah, it also links to these ones on the bottom level, but it directly leads to these 4. Now, when we pick any of these 4 nodes to explore, what we then do is so that we move over to this point. To explore this, what we'll now do is that we would explore if there are any other nodes that extend from here. Yeah, so actually I should use another color so that it makes more sense. So we explore this, and then we explore any other node that stems from here. So right now, there's no other node that stems from here. So once we are done exploring this, then we like go back. We say we are done exploring this. Then we move on to the next one. We explore this. Yeah, however, if you notice here now, at this point, when we are trying to explore this particular node has some other children. Yeah, so we need to explore all the children of this first. Explore this, we try to explore again, we realize that we are done. So we just go back. Yeah, then we explore the next child. Only once we are done exploring the children do we then go back and then go back, then explore the next child. Do you see what is going on? So basically we are going down and down and down. So every node, we try to explore every node all the way to the end before we go back and say, okay, we are done exploring. That is depth first. We are going all the way to the very depth before we go back. Yeah. So yeah, so that's basically what we need to know about this. The other thing that we kind of need to know is the kind of traversals that kind of happen when it comes to DFS. So we would quickly take an example. So now let's say that we have this same example we have up here. So let me just change this back. So we use the same example we have here. We have, and this time let me make it a little bit. So let's say this is 1, this is 2, then let's say we have 3, this is 4, let's say this is 5, this is 6. Yeah, and 1, 2, 3, 4, 5. Okay, so let me just make this one 5. Let me clone this. Make this one 6. Make this one 7. All right, so now when it comes to DFS traversal, we want to explore this tree. Let's say, for example, now we are asked to print out all the elements within this tree. Yeah. So the way we explore this tree and the way we print out the elements in this tree, in that case, now matters. Yeah. And then when it comes to that, there are actually 3 ways to explore when it comes to DFS. And the ways to explore when it comes to DFS are the traversal means. So the first one is the pre-order traversal. The next is in-order traversal. And then finally, we have post-order traversal. So this are traversal. So basically now what does it mean? Yeah, so you go back to the same example when I said that we imagine that we are somewhere here, and then we are going to move all the way down. Okay, so Draw it in such a way that okay. Yeah. So we are here. We need to explore this entire tree. So what we do is we start from here. Start from the first node. Then we go to the left. So actually, let me mark this. So let's say that this is our left. This is our right. Yeah. So that theme will be recurring the entire time. So we start from here. We go over to the left. Yeah. Now we're here. Yeah. Since they are children of this node, we also go over to the left again. And then since they are also children, since there's no child, yeah, we're done. Basically, we're done exploring this. So we go back and we explore this. Yeah, so this is how we move. Go like this, go back. Once we are done, we are done. Yeah, but the way we print out these elements that we explore is what determines what kind of traversal we're going for. Yeah, so what that means is when it comes to pre-order traversal, when we start from here, yeah, before we go over to the next node on the left, we print out the value. Yeah, so when it comes to pre-order traversal, this printing out will be 1 first. Yeah, so we start at 1. Being that we start at 1, we print out the value at 1. Then we get to 2. When we land on 2, what do we do? Once we land on 2, we print out the value at 2 immediately. Then we move over to the next node. We land on 3. Once we land on 3, we print out the value 3 immediately. Then we go back. I don't experiment it. 3 doesn't have any child. So we go back. Then we explore the right child of 2. Exploring the right child of 2, we print out the value 4. Then we go back again. Yeah, we go back. We've seen all of this. Then we go to the right of 1. On landing on the right of 1, we see 5. We print out the 5 immediately. Then we continue to explore the node 5. What do we do? We go to the left, we see the value 6. We print it out. We have 6. Then we go back again. Then we go to the right of 5. And we print out 7. What we have just done is pre-order traversal. So if you notice, what we've done is at every point, the first point where we come across a node, we print out that value. Yeah, so as an aside, I probably should have mentioned this earlier. So a node is basically one point. So one of these circles is what we'll call a node. Then when we say a node, right, usually we could have a value. In this case, there are values in these nodes. And then also it could then have a pointer to his children. Right, in this case, left and right child. Right? So a node could also have a pointer to a left node and to a right node. Yeah, so all of the nodes. So basically, this has this, same thing as this, same thing as this. Yeah, so these are all nodes. However, one important point here is you see these nodes here at the bottom. These ones, for example, this 3, this 4, this 6. They do not have a pointer to any child. Yeah, so basically they have pointers, but the pointers will be pointing to null, a null value. Yeah, so in this case, those kind of nodes are referred to as the leaf nodes. Yeah, no pointer. So if you so let me make this make more sense. So imagine that we have a direction that is defined strictly as going downwards. So in this case, 3 only points to nothing, basically. Yeah. Yeah. So as opposed to if we could think bi-directionally and say that okay, 3 also points upwards. Yeah, but this way we're talking about downwards now. All right, so here's what we have. And now at this point, we've spoken about pure traversal. Let's quickly talk about the inner traversal. So now, when it comes to inner traversal of a graph, or rather of a tree, yeah, now what we do is when we explore a node, when we print out the value of a node. So let me actually, before I go over there, let me just quickly write out the pseudocode for this, for the pure traversal. So for the pure traversal, if you imagine that we have like a pseudocode, right? So let's say, let's call it pre-order. So what we actually do in this pseudocode, from what I've actually shown, is that we evaluate a node first of all. So when we land on a node, we first evaluate it. And then once we evaluate the node, yeah, then we go left and then we go right. This is basically what we are doing. Yeah, and then once we land on any node, yeah, we do the same thing. So once we land here, we basically do the same thing. We evaluate this node. Then the next step is we go left and then we go right. Then, I mean, basically, so this does not end. This continues to happen as long as the node where we are currently on doesn't point to null. So evaluating the node basically means this point now, it could just be printing out the value, which is what we are doing here. So this could be anything. Could be printing out the value. So here we print out the value, we go left, we print out the value of left, then we see if left has a left, then we go to that left. If it doesn't, we can go right. Then we do the same thing repeat. So yeah, so and then once we are done exploring, we go back. Yeah, so basically this was going to be evaluate the node, we go left and we go right. Yeah. However, when it comes to in-order traversal, so in in-order traversal, the difference now is what we do. It basically is going to be the same set of operations, yeah. But in this case now, what we're going to do is we're going to first go left, evaluate the node, then we go right. This is in-order traversal. And let's picture it here. So in this example now, what in-order traversal gives us is we'll start from this node up here. Yeah. So once we start from this node up here, the next thing is we would starting from this node up here, next thing is we would remember we go left. Yeah. So we go left first of all. Yeah. And we are still going, so we are, so at this point when we go left, we have like another set of exploration to go. So this is, so if I call this concept like an exploration, this whole thing an exploration, another exploration. So once we go left, we will now have this whole exploration again to run. Yeah, so that means that you're going to have to repeat the process of going left again. Yeah, evaluating the node again, and then going right. Yeah, so we go left. Now, once we land on left again, we are on another exploration. Then we go left again. Now we are under exploration. We go left again, but obviously this left here has points to nothing. Yeah, so now once we realize that okay, we've gone left, the left value points to nothing. So what do we then do? We then go for the next step, which is to evaluate. So evaluating the node means pointing out the value in that node. So now for in-order traversal, the first node we're printing out here will be 3. So once we are done printing, the next thing we then do is remember we go right. So we try to go right here, but there's nothing here. So we are done exploring. So we can cancel out an entire exploration and then go back. So once we go back, we are going back to saying that we are done exploring a left. We are done going left. We are now going to land on that node and print out the value of that node. Yeah, so in this case now, once we come back from here, you see we are done exploring a left. And in this case, that left is we are done exploring what? The left value of 2. So now we need to print out the value of 2. And then once we are now done printing out the value of 2, we now go right and we explore the right again. So we basically repeat this whole exploration pattern. Once we land on the right, so we do the same thing. Once we land on this right, let's say once we land here, then we try to go left again and go right. Nothing. They don't exist. We don't have anything on the left, so we print out the value there. 4. Once we are done printing out that value, then we we try to go right. There's nothing there, so we go back, and then we go back. So now once we are now about to go back again, we just finished exploring a left of 1. So we now print out the value inside that node 1, and then we now go to the right. So let's now try to be faster now. So once we get to the right, to explore the value of that right, we need to go to the left and see if there's something there. And there is something there, so we print out the value 6. Once you're done printing out the value 6, then we go back, we print out the value 5. Then once we are done printing out the value 5, print out the value 7. This is the inner traversal. So you can see it's just go left, evaluate the nodes, go right. Now, when it comes to post-order traversal, for post-order traversal, the difference is that we are, if you imagine post-order, right? So now, if you think about it, pre-order, okay, so we are, we printing out the value before we explore the children. The in-order, we explore the left child first, we print out the value of that node, then we explore the right child. Yeah, for post-order traversal, we explore both children, first of all, before we print out a value. Yeah, so what that means is would go left, would go right, then we'll now evaluate the node. This is post order traversal. And using this our example, the way that would look is this. So we start from here. We go left first. We are here. We go left again. Then we are here. We try to go left again. There's nothing there. Then we try to go to the right. There's nothing there. We go back. That is when we print out the value 3. So we print out 3 first. Now we are done printing out 3. The next thing is would go, we are done printing out 3, then we go back up. Yeah, remember we just finished exploring the left of 2. Yeah, just finished exploring the left of 2. Left. Then what do we do next? We go to the right of 2. Once we land on the right of 2, we see value 4. Yeah, now at this value 4, we try to now evaluate it. Then we go left. There's nothing there. We go right, nothing there. Then we come back to this node. That is when we print out the value 4. Then we go back. Yeah, so we've explored the left of 2, we've explored the right of 2, then we print out the value inside 2. And then once we are done, we go back again. Yeah, we explored it all everything on the left of 1. Now we need to explore everything on the right of 1. So we go to the right of 1, we land on 5. But at 5, so we need to repeat the same process. We need to go left, explore what value is here. As it have is 6 doesn't have any left, doesn't have any right, then we come back to 6. So we then print out the value inside 6. Now we are done exploring the left of 5. Yeah, so now we explore the right of 5. Exploring the right of 5, we land on 7. Yeah, and then 7 doesn't have any left or right children, then we print out 7. Then now we are done exploring the left and the right of 5. We're done exploring the left and the right of 5. So we come back and we evaluate the value inside 5, we print out 5. And then now we are done exploring the left of 1 and then the right of 1. So we print out the value 1. This is post order traversal. Yeah, so we explore the children first before we print out the value in download. All right. So these are the basic tree traversals when it comes to DFS. But if you remember, the whole point is we go all the way to the depth first before we start coming back. That is the concept of depth first search. All right. So now I'll share some questions in the descriptions that we could use to do some practice. And those questions would talk about these basic things, pre-order traversals, in-order traversal, post-order traversal. I would probably also include some kind of searching questions too that would also help you guys to practice. All right, guys. Thank you once again for joining me in this session. Um, Please don't forget to like, share, and subscribe. And see you guys once again in another session where we'll be talking about the red first search pattern. All right, guys.